once again, hello everyone. In the next 20 minutes or so, I'd like to introduce you to foldable devices. But first of all, thanks very much for having me back at GDG Cape Town. Last September, I had a talk about Jetpack Compose implementing a retro style game, and it's good to be back. So, like I said, thanks for having me. I'm happy to be a Google Developer Expert for Android since last year, but actually I've been doing Android programming since 2009, and along the way I wrote a couple of books. Most of them are written in German, but the last one, Android UI Development with Jetpack Compose, fortunately is in English. So if you're interested in learning a little bit more about Jetpack Compose, maybe you want to give it a try. So, like I said, we are going to talk about foldable devices. Actually, this is a pretty new device category. When the first devices appeared a few years ago, they quickly made headlines because they were not that durable, at least not as durable as the price tag may made us hope for. Like in all first generation devices, these things happen. So the device manufacturers sort of fix these things, and I think the latest devices are durable enough, at least most of the time. If we look at the devices that are available at the moment, we can see sort of three archetypes of devices, and now let's briefly look at them. The first one is very compact. Usually it must be open for full usage, and the screen actually is smartphone sized. Now, the second archetype feels like a smartphone when it's closed, but when it's opened, it essentially becomes a tablet. And the third device category provides some sort of book-like experience. Typically, we see a hinge, which allows us to fold the device in a 360 degrees angle. And you can use the device in various postures. Like I said, you can use it like you would be holding a book, or you can use it like a tent, which makes an really awesome alarm clock, or you can put it half open on your desk and watch videos. Well, on the next two slides, I will be showing you how using a foldable device looks like from an app perspective. The first slide shows the Android emulator when run in foldable mode. It basically shows how an app responds to the device being folded or unfolded. So let's take a look at it. As you see right now, the device is folded, so it looks like an ordinary smartphone. Now I start opening it, and then you see that the app makes use of the extra screen real estate, while when I fold the half of the screen back, it then again becomes an ordinary smartphone. Now the thing repeats. So let's go to the next slide. The next slide shows an emulator that simulates the Surface Duo by Microsoft, which is a dual screen device. Here the experience is like this. When you launch an app, it usually is open on the first screen, and by some drag and drop gesture, you can have the app expand to both screens. And as you can see, you can move the app around the screens and make it small, make it big again. And here I tried to dismiss it. It didn't work in the first place, but well, it's a small lag in the emulator. Now, this is how the experience is. What can we say about foldables? They may have one, two, or possibly even more physical screens. And these physical screens may relate to one, two, or possibly more display areas. Now, what's important, the biggest area may be provided by either one physical screen. In this case, this physical screen has some sort of fold. The latest Samsung foldables work like this. Or the biggest area can be provided by two physical screens which are connected with a hinge. And this is like the Surface Duo devices from Microsoft work. Now, the thing about the hinges, it may block or obstruct parts of the display. Please note that having a hinge does not necessarily mean that parts of the display is blocked. Like I said, if the foldable device is made from one foldable screen, then there may be a fold, but that usually will not be noticeable, or at least it doesn't separate the two halves of the screen. But if we have a hinge and if it does block or obstruct parts of the display, it may look like this. On the left-hand side, you can see the book-like experience. Actually, I enjoy using my foldable device as a reading device very much because it very nicely resembles the way you would be holding a book. And this experience is really great. If you look at the screenshot in the middle of the slide, here I'm playing a video. In a way, the hinge does make the UX a little less pleasing, but you can work around this by, like I said, turning the device and folding it halfway up. So the video is displayed on one half of the screen, and the other one can be used for any other parts the app may be providing. On the right-hand side, we see the phone app as it is currently on my Surface Duo. And as you can see here, clearly the UI needs some tweaking. First, we have the hinge obstructing parts of the content of the app, and additionally, the hinge also obstructs part of the, let's say, top level UI. Here we have bottom navigation, and the navigation item in the middle is barely visible, and this surely is something we need to fix. Fortunately, it can be fixed pretty easily, and that's what the remaining part of this talk is all about. Conceptually, we can divide the screen of a foldable device into three areas. I labeled them A, B, C. Obviously, A and C represent parts that can actually contain the UI element of the app, whereas B is the hinge that may block or obstruct the content. So what we need to do in our app is find out where these three areas are and how big they are. And once we have obtained that knowledge, we need to define our UI in a way that the hinge, that is area B, does not interfere with the user interface. So how do we do that? How do we do that? The user interface certainly must be laid out accordingly. And now the important thing is for tablets, using two-column mode worked pretty well. And as foldables are like tablets with a hinge or a fold between the two halves, using a two-column mode should work equally well. Before I turn to the next slide, allow me to remind you that having two columns does not necessarily mean that the two halves are of equal size. If we look at typical tablet apps, we usually have a distribution of 33 to 66%, meaning that the left-hand side usually takes 1/3 of the space that is available horizontally, and the right-hand side is 2/3. But this would not work too well for foldable devices, especially if the foldable device has two similarly sized screens. So having two columns that have a 50% to a 50% ratio will give us a very smooth experience. And now let's see how this works. So let's see how these two columns will help us make nice, good-looking user interfaces. Before we do that, creating two-column layouts has always been easy using classic views, and it certainly is equally easy using Jetpack Compose. But the interesting question is, what about the hinge? How do we deal with it? How do we get its features? And what do we need to do to work around it? Fortunately, there's a library for that. It's called Jetpack WindowManager. It's part of the Jetpack library of components. And, well, let's see how it works. The main idea of Jetpack WindowManager is to support new device form factors, and as we need on the Surface Duo, also support multi-window environments. It does so by providing a common API service for all platform versions, starting with API level 14. The initial release targets foldable devices, but Google told us that future versions may embrace additional devices and additional features. So what does it do? Basically, there are two main areas where we get help. It helps us computing window metrics. You'll see soon for why we need that. And the second thing is it helps us getting window layout information. It has a nice flow-centered API, but if we want to use Jetpack WindowManager with our legacy Java apps, we can do so too. It also supports other asynchronous APIs. Here's how to use it. The first line is mandatory, and the other ones are needed if you need Java-friendly API or if we want Rx Java 2 or 3 integration. Here's how it is typically used. The first code snippet shows you how to get window matrix. We need to get an instance of a thing that's called a window matrix calculator. And on that object, we invoke compute current window matrix. Here we pass a context. And the second thing we can obtain is the window layout info. Here we see two possible approaches. The one in the middle is typically used for non-compose apps. Here I'm iterating over something that's called display features. You will see shortly what these display features are and what we can do with them. The last one is very compose friendly. We can get the window layout info as a state. This is what I am doing in my sample app. So let's see how this works. But before we do, let's take a closer look at what window layout actually is. What you see on the slide right now is a sample app of mine. It's called WindowManager demo. It's no Compose app. It uses Android views and view binding. It basically prints out the current window metrics, and it basically prints out the window layout information. Here you can see that there are a couple of bits of information we can get about the hinge. For example, we can get its location and its size. And we can also find out if the hinge has a horizontal or vertical orientation. What's interesting is the so-called occlusion type. If, like here, it is set to full, this basically means that the hinge is obstructing parts of the user interface. So however we lay out our app, we need to make sure that no information lies beyond the hinge because it won't be visible to the user. Is separating is a hint that the two parts of the screen are somewhat Independent meaning we probably should not have a video screen or text layout or something like this that stretches over the screen completely horizontally or vertically, because then again, parts may be obstructed by the hinge. Typical Samsung-like devices which do not have two physical screens, they might show occlusion type none. In this case, the information that there is a hinge is, or a fold in this case, is some sort of informational purposes, but we can continue to lay out our composables like we would on a tablet, because there is a hinge or fold, but it doesn't block or obstruct parts of the user interface. Here's how my sample app looks like on the Android emulator configured as a foldable device. Here we also have a hinge, but this hinge is only 1 pixel wide. So basically it doesn't do anything that makes the UX less pleasant. So if you are writing an app that should work great on foldable devices, I encourage you to use not only the Android emulator, but also get the emulator from Microsoft for the Surface Duo, because you probably should be testing your apps on devices with 2 physical screens as well, to really make sure that the experience is the way you want it to. Now let's take a look at some code. The sample app I will be discussing right now actually has 3 scenarios. The first scenario is if it runs on an ordinary smartphone, meaning no hinge or fold at all, or a hinge that does not block or obstruct any part of the user interface. If the app detects a device like this, it just shows one yellow box with a thin white border on all 4 sides. If, on the other hand, the app detects it runs on a tablet, that means larger screen with no hinge or fold, it shows 3 boxes, a red one, a green one, and a blue one. And the third use case is the one that's actually the most interesting for us. It's if we are on a foldable device and that device has a hinge, we are showing 2 rectangles, a red one and a green one. Now let's see what my code does to achieve this. First of all, here's the onCreate method, which basically sets up a Compose app. As you can see, we have the set content. The set content gets a scaffold. The scaffold has a top app bar, and the actual, well, user interface comes from a composable function I call content. And what's interesting about content, it receives 2 parameters. The first one, metrics, is basically the window metrics that we got from the window metrics calculator, compute current window metrics. And the second parameter is the window layout info, and I get it by invoking collect state. As I'm using by, I do not pass the state to the composable function, but the actual value, which is the window layout information. So now let's see what we do with this. Basically, the content consists of a surface, which may be used in various Compose apps to provide some sort of background. We can use this to set colors and things like that, or set some things like elevation. That's not too important here. What is important, that the next thing I do is I compute the width of the screen by using local density dot current and passing the width of the window matrix. And once I have converted this to density independent pixels, I check if the screen width is less than 600 dps. If this is the case, then I assume I'm on a smartphone, and then I draw only the yellow box. Now, what's interesting here, I said that I check if I'm on a smartphone that has no hinge. That's not entirely true. I mean, even if there were a fold, I would not further work with it, because I think if the screen is less than 600 density independent pixels, it probably makes sense to treat the screen as it were an ordinary smartphone display. So, but what happens if the screen is at least 600 dp or wider? Here's where the interesting part regarding Jetpack WindowManager happens. Essentially, I'm computing 4 values. The first one, has gap, determines if there is a hinge, and we do this by getting a list of so-called display features from the window layout info. Display features basically describe some sort of anomalies that may happen to the screen. So far, only one display feature is handled by Jetpack WindowManager. It's called the folding feature. And this folding feature provides us the values you saw on the previous slide, where we get information about the hinge. And what I'm doing here is computing these 4 values based on the information I get from the window layout info. For example, I assume that the device has a gap if the occlusion type is set to full, and if the orientation of the hinge is vertical. Now, this means that if the device has a hinge that blocks or obstructs part of the screen, but the device is rotated so the hinge runs along the horizontal axis. Currently, my app does not react to this to make the code easier to read and to understand. In your app, you may want to target this situation as well. Now, you may be wondering what size left and size right represent. Actually, here I'm computing the width of the area to the left and to the right of the hinge. You will see shortly what we need this for. Actually, it happens on the next slides. So here is where we decide if we are going to show 2 colored boxes or 3 colored boxes. Please recall that if I determine that there is no gap, meaning there is either no hinge, or if the device is rotated so the hinge runs along the horizontal axis, then I assume tablet mode, meaning that I'm showing 3 colored boxes. That's in the else branch. And the interesting thing happens in the if branch, meaning if we determine that there is a gap. And here I'm using the sizes of the left and the right area to obtain a weight. Weight is something you may be familiar with from the classic linear layout. Basically, we could size parts or children of the linear layout by specifying weights, and fortunately Jetpack Compose has something similar, and I'm using the width of the 2 areas in combination with the width of the screen minus the width of the hinge to compute the weight. And actually this weight is just passed to another composable function. It's a small composable I implemented. It's called colored box with weight, where the weight is just passed. Now, what have we seen so far? We now know how we compute the three areas A, B, and C, which means that we can set up our user interface in a way that we have two columns, and we can populate the two columns, which are represented by A and C, in a way that we get a nice looking user interface. And we also have determined the features of the hinge, which was represented by the B area. What we haven't discussed so far is what will we do if the hinge obstructs part of some top-level UI elements. Here in this example, we have two top-level UI elements which are affected by the hinge. The first one is the app bar at the top of the screen, and the second one is the bottom navigation. So what do we do with this? So how can we make these parts, these user interface elements, hinge aware? Now you are seeing a clip which shows an app I called Navigation Rail Demo. This is because Jetpack Compose 1.1 received several new composables. One is called the Navigation Rail. Navigation Rail is the implementation of user interaction pattern provided by Material Design, which essentially is used to provide navigation where the navigation items are arranged vertically, and the spec says we should use the navigation rail on large screen devices like foldables or tablets. And my sample app showcases the navigation rail in a way that it is used when the device is rotated to landscape mode. And if it is not in landscape mode, but in portrait mode, I use the traditional bottom navigation. At the end of the slides, there is a resources section where I will provide you with links to my samples. But as I said, here's how the navigation rail works. And now let's briefly look at it in some more detail. The navigation rail is used to move between primary app destinations, like the bottom navigation is also used. It can display 3 to 7 destinations. It can have an optional floating action button, and it can have a logo inside the header. It is populated by so-called navigation rail items, which represent these primary destinations. Here's how this looks in code. We have the navigation rail, which receives the navigation rail items, which in turn receives an on-click lambda. It receives information whether it is selected or not. And we can set up an icon and a label. That's basically all about it. Time for some brief wrap-up. You've seen that the two columns work great for tablets and foldables, and with Jetpack WindowManager, we can determine both size and location of the hinge and the areas to the left-hand side and to the right-hand side of the hinge. Sometimes the hinge obstructs top-level elements. As you've seen, Material Design interaction patterns help us minimizing the impact. In some cases, there may be some more work to do. A few months ago, I did a short article on dev tool called Hacking the Hinge. This is where I am looking into how to sort of hack away these issues. And like I said, here's the links to my sample apps. And that's about it. Thanks very much for listening, and I really hope you enjoyed listening to my talk. Thanks very much.
Very nice, Thomas. Very, very nice. There aren't any questions in the chat, but I'm just curious. So why the interest in foldables? Do you have a device, a foldable, and then you're like, no, I need to try and figure out how to decompose on this?
I have to confess, I'm what you probably would call a gadget junkie, meaning if there is any new device, I need to buy myself one. And I mean, Microsoft introduced the Surface Duo quite some time ago, but it took almost a year until we could buy one in Germany. And once I could, I needed to buy one. So yes, I do have a foldable device. It's the Surface Duo, and I needed to acquaint myself with it. But besides that I think it's, from a developer's perspective, it's very important to know how to deal with these devices. But I think they will be gaining steam in the near future. I mean, for now, these things are awfully expensive, but I'd hope that in the months and years to come, the price tag will significantly drop, meaning that even more people can afford to buy them. And once there is a solid user base, we need to make sure that our apps work flawlessly on these devices. So that's why I'm sort of advocating foldable devices, because as you've seen, there is some work to be done to make our apps really shine on these devices. And that's, in a way, I consider this my mission to advocate these new devices. And one last thing, there might be a foldable device from Google sometime, and I surely need to buy this as well. So I need to justify buying new devices in a way.
No, I love it, man. I love it. I actually learned so much about foldables. Yeah, no, it does a really great talk. Thank you so much. We actually
My
have a
pleasure.
question from Catalin Gita. So he says, actually, I have one, which is a question, non-technical really. Do you think foldables are some products that will become popular? If so, we might need to invest time in learning how to deal with these devices.
Yeah, absolutely. It may take some time. I mean, if you look at the price tag, this is speaking in euros, this is way beyond 1,000 euros, which is an awful lot of money. But like I said, I think the prices will drop sooner or later, and then these devices will become more popular, because the nice thing about them is, as you've seen, they can be really compact, meaning they can really nicely fit into the pocket. But once you open them, you get a really large screen real estate, which is a pleasure to use. So yes, I think they will gain popularity sooner or later. So we should acquaint ourselves with them.